Okay, so we're going to do a review of the midterm, and I'll just show you. I'm going to share my screen now. And anyone who has any questions, feel free to ask. I feel like if you want to ask specific questions regarding the practice midterm, feel free to chat with me individually. Then I can try to reframe those specific questions in terms of generalities. I think we kind of did that already, and that's helpful. I'm going to stop my share. I'm going to do a new share. And I want to share actually just the PowerPoint here. Okay. I'll do a little slideshow here. All right, so a couple background pieces here. Basically, there are 6 areas. Just think of if we can condense the practice midterm to 6 areas, it's the 6 weeks that we have covered so far. Now, if you haven't taken the practice exam, please do it. We're going to review that and on Thursday. And I hope that it gives you an opportunity to raise questions or areas of concern that you have sort of experienced already. Now, some of this might seem basic, but I've had many students in the past say to me, I did so well on the practice exam, but then the midterm exam, well, maybe I did better, I did worse. But the emphasis I want to give on this, on the practice midterm is, in terms of content and the sort of the experience, it's going to be identical to actually taking the midterm. That is to say, we're going to provide you with a window of opportunity. I think we release the midterm exam for Thursday, and then you have to complete it by Tuesday. So you have those many days, 4 or 5 days to complete the midterm exam. Once you start the midterm exam, you're going to have a couple hours, 2 hours actually, to finish all the questions. We made sure that it's not, how do I put this? We made sure that the midterm exam is not a race against the clock. That being said, keep this in mind. There is a kind of a window of opportunity here. So, we all have busy schedules. We all are balancing many different roles, professional, personal, familial. So my advice is try to find a quiet place for 2 hours or more so that you kind of have everything in place. That means simply, this is how I survived the graduate record exam when I applied to go to graduate school at Harvard. I basically just sort of didn't let any distractions in my environment bother me. I brought a snack, I brought a drink, some water, and I also made the environment comfortable. I surround yourself with flowers, or I have flowers here. Maybe think of what helps you. Whatever it is, I think it's important to keep in mind that there is a time limit to the exam, but you're not being penalized or rewarded on how long it takes. You can take the full 2 hours. And again, the goal is not a race against the clock. I can tell you, as this practicing statistician, as a colleague of mine has said, they don't call it research if you have to look at the data once. So it's not going to be, statistics is a lot about trial and error and discovering concepts and thinking things through. It isn't about necessarily doing things quickly. Although in practice, there's a big debate, and how accurate do you need to be in terms of how much do you need to push the results through. So there's always that tension, but I think we're definitely just want you to feel comfortable, and I think those are important parts of, I would say, taking the exam in a way. So if you have taken the practice midterm, then you already have a good idea of what the exam will be like, and maybe where areas of strength or weakness are for you individually. If you haven't, I recommend you think and keep in mind the sort of definition of the situation. In other words, how do you want to structure this so that you make sure that you don't have, say, calls from your parents or some familial engagement or something. You know, life intervenes. I just want to make sure that that doesn't ever really become an issue. Concomitantly or concurrently, I don't want anyone to feel like that they are handicapped or don't merit a good grade in this course. And that's the only way I'm going to put this. Because what I see more often than not is students know the material, but then maybe might feel other non-intellectual, non-cognitive aspects of the test-taking environment intrude on their performance. And I think that's just more, it isn't just, it is an important part. And I've seen this with many students. There's actually one of my colleagues, she's a, you could say motivational speaker, but she's a social psychologist here at Harvard and does a lot of work on leadership and talks about presence. She wrote a book called Presence, and she talks about the imposter syndrome, which is very common. Now, what is the imposter syndrome? Well, the imposter syndrome is the idea that, well, if you are taking a Harvard course or I'm taking a Harvard course, that Harvard sets such a high standard that everyone who's a participant is an imposter. And I can tell you, as a graduate student, when I started out, I moved many thousands of miles to move to Massachusetts and go to Harvard. I didn't feel like I fit in. And I know many people, no matter how many accolades or rewards they get, they often don't feel like they fit in. This is the idea of the imposter syndrome, that it's that collectively people may not feel like they belong, that maybe they are not worthy of doing well. And I see this more often than not. This is more perhaps those of you who feel like, oh, statistics isn't for me because I don't like math or blah, blah, blah. Ignore all of that. And I think that's where I see the biggest difference in terms of the practice midterm and the actual exam. It's easy to say get rid of the imposter syndrome, but look, I'm basically helping to develop this course. I'm here as, in a way, a gatekeeper. I'll grade this exam and evaluate you on your final projects. Here I am telling you, I know some very successful people, all of whom have at one point or another experienced the imposter syndrome. So it's ubiquitous. It happens everywhere. It's also something just to acknowledge and just to differentiate between, okay, here I am in a particular environment where I might feel emotionally anxious or something like this because I feel like I'm under pressure, as opposed to, do I know the material? That's the whole idea for me when I think about, okay, when I prepared for all the exams that I've taken in my life, I almost always, in a way, took the tools that I had from Boy Scouts. Be prepared, right? Or from camping, basically. The idea essentially, make sure you're creating an environment that's comfortable, that doesn't make you, where you're not basically sabotaging yourself. That being said, I know life intervenes. Communicate with me and let me know if some issues arise that, were out of your control. Family illness, for instance, or, an accident or something like that. But I think that's terribly important to recognize that the imposter syndrome is everywhere. I've certainly felt anxious in exams at Harvard, my first exam. And when I first took stats, I remember, I was pretty terrified, but we all start somewhere. And that's different than intellectually knowing the material. And I think that the emotional part actually doesn't get enough attention. But if you're going to see a discrepancy between the practice midterm and the actual midterm, that's the biggest difference, I think. So I know a lot of you have families, so this is probably where you want to take the kids out to a park or something like that, and get everything organized. Okay. Any other questions about? I think maybe about. I don't want to focus too much on this; it might seem trivial. But I guess we could say about the emotional, socio-cultural aspects of the exam, or maybe the exam experience itself. Okay. Maybe I'm seeing some comments, I'm not sure. No. Okay. Okay, no questions. Is that right? No questions? Yeah, someone's asking about notes. Yeah, notes are fine. We're not testing about whether you can memorize things. We're just testing, we're evaluating your performance. One thing to keep in mind, in contrast to everything else we've done for the course, for both the midterm and the final, we have a larger question bank that we draw from. So just to let you know, there isn't exactly one exam that you're going to take. So you can't exactly, if you and a study buddy are doing the same, midterm at the same time, you might have some questions that overlap, but they might differ slightly. Everyone's experience is a little bit unique. We do that in part because, I remember going to college and seeing fraternities basically aggregate answers. We don't do that. It's just a sort of a preventative measure. We have a sample of questions in a question bank. So that's important, though, to keep in mind if you're thinking, oh, gosh, my question is different than the other person. We're not adjusting to previous performance. There's no computer adaptive system here, but there is a sort of a random selection of questions that are within different pools. That's a good question. Someone is asking, is the score displayed after hitting submit? I will ask about this because this is actually something I don't know, because we used to actually require you to sit for these exams. But since we've moved totally online and used Canvas as the interface, I can't give you a correct answer there. I want to err on the side of caution. Yep, it's going to be the question format, even though we're going to, each person will have a sample of questions from the question bank. The format and the types of questions are going to be very, very similar to the practice exam. So if you soar through the practice exam, good. It's not going to be an issue. Okay, someone is asking, like, would it be similar to the practice exam? The other question is, I thought instructions required fill-in responses, which require grading. Okay, so there are some questions where we ask you, I believe, to type in the answer. Is that what you're asking? Okay, so yeah, so the question that required a type-in answer, yeah, some of these require grading. Okay, so thank you for that quote. So this looks like this is the prompt from the midterm exam. It says, actually, this is through, again, I apologize for not having a ready-made answer here. It says, when you complete the practice midterm, you will see the correct answers. That's very true. The practice midterm is very different than not very different. It's only different in this one respect. For the midterm and the final, we have a question pool, question bank, and we sample from that. So your questions that you have are going to be slightly different than those of your peers. That's important to keep in mind if you think there's an issue there. It's also relevant for getting the grading done. And the other reason, of course, is didactic or pedagogical. For the practice midterm, our goal is to really give you an idea of the content that we're presenting so you can get immediate feedback as to, oh, okay, these are the kinds of answers that we have here. So as the prompt says for the practice midterm, it says, please note that seeing the correct answers will not be the case for the actual midterm exam. You will not be able to see the correct answers until after all students have completed the midterm course. And the course staff have had the opportunity to grade the open response portion. That's exactly right. Thank you for that. I'm sorry, but that's right. So someone else is asking, well, maybe we just have to confirm. That's exactly right. Look, we do make mistakes in terms of, like, especially if you're doing a write-in question, there is enough rounding with propagation of error or rounding errors or discrepancies, rather, not errors, that are consistent with the correct response. And that's true for the write-in answers. So, we do vet and we do look at everything in your profile about, the questions that you answer. So of course, the main point is you're not going to, of course, I'm sorry this didn't cross my mind, but of course you're not going to see what you did on the midterm until everyone has completed theirs, because we just want to make sure that everyone has completed the final exam before we can actually make any particular comments about them, right? In the same vein, I can't give you any specific comments on the practice exam because I don't want to sabotage those students about the practice exam who haven't taken it. But I will cover the practice exam in terms of like generalities or concepts. I hope that helps. In contrast to the missions, at least I will, when I always do this when I grade, I'll give you sort of a overall feedback of like, okay, well, I think this, maybe you might want to focus on this, or maybe this is an issue. I'll typically write in Canvas sort of any issues that might arise. I hope that helps. Yeah, but the main point is you will not get the, we will not release the midterm grades until we've sort of finalized everything. But that being said, our goal is with you. We want everyone to get an A. We want everyone to do well. We want everyone to be, you know, I don't know. It's tests are a weird thing, right? I'm sort of like, yeah, we will. Someone's asking about probabilities. Oh, okay. Yeah, so, yep, we will focus on difficult problems. I think one thing I haven't addressed, I talked about the emotional part. The other part is maybe, like, if I were to create a cheat sheet for this course, it might differ. It really depends, but I think the best way that I would study for the exam is I would probably, well, actually, I would definitely do this. I would write out the equations that are most relevant, have an equation sheet. And keep in mind that we're not testing you on mathematical ability, but we're not rewarding miscalculations. So just make sure, you know, if you want, I mean, I have a friend who's a lawyer and he has like this giant calculator with giant buttons. Okay, he's a lawyer, you know, he studied philosophy. He's a wordsmith, but there you go, exactly. Those equations are useful because sometimes we'll bring them up. Now, I don't want to give anyone a feeling of overwhelm here because sometimes there are different ways to solve an answer. But like, for instance, the equation for a correlation is going to be useful. The equation for a simple linear regression is going to be useful. Some certain relationships between concepts, like standard deviation and variance. To know that variance is a square root, sorry, standard deviation is the square root of variance, is relevant. So just some of those linear transformations are important. Good, and so that being said, if you want to print out everything, I've done this before too on exams. I had generals exams in graduate school, which was 3 essays, 8 hours long. Actually, that was a closed book exam. Never mind, I had to memorize everything. But I have taken other exams where it made sense to print everything out. So it all depends on your style of learning. But the point is, we're not quizzing you on memorizing junk just to memorize it. It's really more about using critical reasoning skills and kind of, in some cases, knowing what is assumed when we ask certain terms. So I would actually say, someone else is keying on what are difficult problems. So that's an interesting question. I think, for most of you, it seems like what looks like a more difficult week. I just sort of looked at the aggregate. It seems like some of these questions related to probability and relative risk seem to cause a little more concern. And there were a couple interesting sort of discrepancies with regard to simple linear regression. That more has to do with, I think, just identifying the output and writing out the equation. And I did review a lot of this stuff, of course. So this is, again, a review. So some of you might have already seen this. But I think from what I've seen, you're going to see most of the equations probably, well, actually, I'll say probably. Definitely, it'll be beneficial to know what the equation for a correlation is. And just to know and interpret some of the concepts for simple linear regression. including the equation. You know, how do you predict a value given another? And then there are quite a few concepts, but mostly know what write out the equation for relative risk. And then we're going to cover some of these additive rules that I think are relevant. That's a good question. Someone had asked, what's the average finishing time? That's a really interesting question. I actually don't know for this term. Well, we wouldn't know for this term because we haven't collected the data yet. You know what I'll do? I will take a look at the practice exam and see what the average finishing time is for that. And I'll see if I can look at previous terms data. That being said, keep in mind, the average finishing time what is it? It's a measure of central tendency. Average is a measure of central tendency. Well, what's the problem with an average? Right? If we look at the average finishing time, there may be a few who are, and we've had students like this. Maybe they want to learn R, for instance, so they want to work on a project, or they're busy and they just kind of want to get another perspective on the general course that they've taken. Those people are going to finish pretty quickly. And those people are often going to skew the average and maybe push it down a little bit. That being said, I will look into the average because I think also what is relevant though is also the spread. What is the distribution? I'm not sure, but I do know that some people will take all 2 hours. Now that doesn't mean that they're racing against the clock. If I were taking this class exam, because it is important to me, and I'm sure it's important to you, your time is important, I would take all 2 hours. That's just me. I know when I've taken stats exams, I remember, one student in my class, I could do better than her. I could do faster than her. I couldn't do both. I couldn't maximize both dimensions. Some people just want to take the exam and go. That's fine. It might be considered a waste of time to overstudy. Well, I always like to double check my answers and kind of, repeat things. So the reason I'm saying this is in some ways, an average completion rate doesn't tell you how long it takes to actually give it a pass. And in fact, that's how I'd address the practice exam too. Not only an identification of areas that maybe are cause for concern, but also to consider maybe how you might want to triage, to use a medical term, if you're a nurse or in the medical field, you're talking about triaging patients. This is really allocating resources. So you can focus the most time on those higher point questions or on questions that might be of more of concern to you. So, exactly. So someone else is saying that she submitted her practice exam and with 1 minute to go and 2 hours to review answers 2 or 3 times. Exactly. That's what I would do, to be honest. Had 1 minute to cut off for time. And to be clear, even with the right-in answers, we're not asking for precision. I've always said this. If there's one thing I can talk about, I can criticize precision. I had a professor who said, I memorized pi to 3.1423774569919112. Now, this is the person who wrote basically the manual, the Bible on a whole field called maximum likelihood as a kind of a statistical model. And I think everyone in the class thought that this guru basically, this stats maven, memorized pi to like 20 digits. No, he didn't. He basically said, no, I just made up all the digits after 1.14. Because it doesn't really make sense. When we talk about statistics, we're using this word model quite often. It's because we're not looking at precision. We're doing an estimate of our best guess. And because that best guess, as we'll talk about in the second half of the course, is always estimated with some, see, I'm using that word estimated. When we talk about an estimation or even a prediction, what we're going to go focus on in the second half of the course is recognizing and identifying that there is some kind of range of, you could say, I'm trying to use a term that isn't going to be too confusing. You could say a margin of error in a way. You're always making your best guess here. So yeah, I would say that's important to do. Now, a technical issue, one I had today, right? I had an internet issue. Who do you call if something happens online during the exam? Well, the first thing you should do, first of all, if it's a local problem, focus on that. That being said, we have, like, Canvas is, well, I see 3 issues that you might encounter. I'll just say in terms of technical issues. One, it could be a local problem, so make sure you connect it to your router. That's what I had. The second issue is make sure that you're logged into Harvard and you have the correct credentials there, right? This is, if you have Harvard Key, you should have a push notification or something like that. So make sure that you have the Harvard credentials. If not, you need to talk to Harvard IT. Now, the third issue might have to do with Canvas. This is very rare, and it would be a sort of a system-wide issue because I guess Canvas operates on Amazon servers. I guess it's been down for a while, but it has never been down for an exam. So I would say contact Harvard IT. Now, that's if you encounter a problem with the exam in terms of sort of technological access. That'll also deal with maybe issues that you have with your Harvard Key server. Has anyone had any problems with the Harvard Key access? Okay. Okay, I wouldn't think so. You know, that being said, this is sort of like, again, before I take the exam, I would bolster more time than you need and also just set this, you know, make everything set up and make sure you're logged in. Let's see. I'm just going to get the computer lab for DCE. So I guess I think you can just log in here. This will probably help you for contact. I think you have to log in to Harvard Key. I know that FAS, technically we're affiliated with FAS, but I think you have to go through DCE to actually get someone who might have more training regarding the course website. Okay. However, I'm sorry, I didn't mean to do that. I had to give the URL to everybody. If you just go to harvard.extension.edu, sorry, dce.harvard.edu, you go there and you should find Harvard IT. Here. I'll just stop a share and I'll do a new share. I know this is like, well, what does it have to do with the material? It's sort of, this is for the DCE lab. I believe you can use the lab. You should be able to use the lab for taking the exam if you're on campus. That being said, if you have questions regarding, let's see, regarding online issues, you should do go click on support. If you go to DCE, I want to add that to the reading list. You should go to, let's see if we can find information here. Yeah, you can see their information sheets. You can see lab rules. There's somewhere around here, there's contact information. I would go here, but I would say above all, if you're encountering any issues regarding technology or anything else, an act of God comes in and, you know, just rearranges everything, contact your assigned TA. Now, half of you are assigned to me, half of you are assigned to the other TA. The reason is that while we share the teaching staff we all share office hours and times to meet with you, when it comes to this nuts and bolts issue of what grade am I going to get for the class, that's crisply defined between your different TAs. And I can probably identify you, whether or not you're in my section, but basically, if you have no one else to turn to, or you have an issue, contact us. We'll get back to you, especially during this exam time period. I want to make sure that everyone, you know, No one has an issue. So I don't look in a sample that's large enough. Stuff happens. That's true. But just as long as you can communicate with us, that's I know you know, as long as you're doing the best that you can. Again, it's not a race. We're not punishing you for any of that kind of stuff. So apparently I went to the DCE website, and for some reason I couldn't get the IT there. But okay, anyway, I don't want to distract from the issue at hand. I will, actually, there you go. If you go to contact us, there you go. Here is the main number for DCE, where you can actually, I think you can get them for help. Yeah, the reason I'm directing you toward the Division of Continuing Education IT help desk, as opposed to FAS, Faculty of Arts and Sciences, is that DCE is well qualified for dealing with distance learning issues. Okay, so there's that one issue. In my 2-hour time period when I start and end the exam and I clock out, what happens if you don't finish? You're gonna get zeros on those answers. So if there's 5 minutes on the clock, something happened, and you find 5 minutes left, answer, please. You will not be penalized for wrong answers, but you will definitely be penalized for answers that you never tried. So please, 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 just, half the time it's multiple choice. Answer, please answer. Another question is related to the write-in answers. Yes, there are write-in answers. And as I said, we do verify your answers and we do look at the distributions, and I will have a little, as I said before, sort of a midterm evaluation, not an evaluation, but just sort of feedback. So it's like, okay, this is good. Or, if I have a concern, I will suggest we meet up or chat one-on-one, just so we can, make sure that any issues that are of concern are addressed. So yeah, I forgot what else I was going to say. Okay, now the last thing to keep in mind is for the final exam, you're going to cover both this 6 weeks that we've covered and the last half of the course. In other words, this first half of the course you're kind of double dipping. The midterm covers the first half of the course. The final covers both the first half and the second half of the course. That's crucial to keep in mind, just because, hey, might as well learn this material now because you're going to deal with it again. And if you know this material, have it down pat, then you're going to get double points for it. That's something that's kind of like a little hack for the course that I think isn't entirely clear. Okay. I'm going to share the screen one more time, and I'll just take it back to the PowerPoint. And then I'm going to get to the lectures, and oh shoot, it looks like my PowerPoint closed. Oh, here it is. There we go. Okay. Okie doke. Okay, simple linear regression. Essentially, we're going to just cover all of this stuff. Now, the other thing I've always heard from the students on this class is that the second half, unfortunately, is harder than the first half. Now, why is that relevant? Well, it seems like that's the case, and we try to ratchet it up, and we'll give you more help, but it's also because maybe students are more busy. The second half requires a bit of a cognitive shift. If you notice, I was even balking at the language I'm going to use. It's central to stats, and it has to do with inference, right? If you have a smaller sample, how do you infer to a larger sample? Here, we're really just doing description, and what are the variety of ways to describe things, basically, with an emphasis on probability. Okay. I want to get back to the write-in question. Someone asked about this. When you do rounding to 2 decimal places, that's typically what we're going to do. So in other words, just to be clear, if we're asking for a correlation coefficient, what is the correlation of coefficient? Then you're going to write, say it's you estimate the correlation coefficient to be 0.5322. Okay, just round that to 2 decimal places, 0.53. And again, we permit a range of possible answers. So again, we're not looking at precision, but the rule of thumb is if it's a decimal place, sorry, if it's a coefficient that is defined as like like in terms of probabilities, as like in terms of the decimal places, round to 2 decimal places. If it is a whole integer, like a percentage, typically we're going to ask you to do like report percentages in whole integers. So 71%, 70%. We're not going to be overly precise in those kinds of answers. Typically 2 digits is going to be a sufficient answer. And we understand that there'll be variability there. Okay, I want to get to what I think is important, the equations, and I'm going to just take you through what I think is relevant. But any other questions about maybe sort of the architecture, the flow of the midterm exam? No. Okay. Hold on for a second. Sorry. Looks like my screen might be dimming. This is the problem about seasonal change. Okay. So actually, I'm going to take you to, sorry. Ugh. I'm trying to open up the lecture notes. And oh, zoot. Is my screen freezing? Okay, sorry about that. Looks like my screen froze just momentarily. I'm going to take us to let's see. I'm going to take us to the week on probability, because I think out of all weeks, that's the one with the most equations, the most questions that I get. If not, please let me know if you have any questions. But I think that's by far is going to be the biggest one. So let me direct you to that. Oh, thank you. Okay, thank you. Sorry. Okay, sorry about that. I'm gonna do a new share, and I'll do a share with the lecture notes. Oh, here we go. Here, I'm actually gonna pause the share while I can. So I'm gonna share with you the slides for week 4. I'm just going to skip ahead to the first 3 weeks, mostly because I think this is where students have issues. Otherwise, I wouldn't worry too much about it. But it's sometimes nice to get a big picture, sort of how do all the concepts fit together. I think this is probably the best approach to sort of think about what it is we're learning for this first half of this course. We're talking about descriptive stats. I said this to you before, but essentially this is everything we're doing, and there's a pretty hard line between descriptive stats and then sort of inferential stats, and we'll talk about this later. But don't worry about inferential stats. We're just going to do everything about describing, the data at hand. Now, why is that a key distinction? Why do we create this rupture here? Because descriptive stats don't tell us really much about anything other than the data we have at hand. And central to stats in general is this idea that from a finite sample, from like a survey of 2,000 people, you're able to infer the opinions of 330 million people. That's pretty remarkable. However, because of advances in machine learning and big data analysis, often all you need to know are the descriptive stats, because we already have complete information on everyone, right? So that's I think, an interesting dynamic in terms of the history of stats. And I would say, also, when we think about this week, don't get a short shrift to the introduction to data. Just know those concepts, know what the difference is between categorical data, numerical data, different kinds of experimental designs, observational designs. If you know what an observational study is, that's a crucial distinction. Observational means we're not factoring out a single causal factor. We're not running a controlled experiments to compare a treatment and control group. But I think starting from the ground up, we really give you, I think, the easiest ramp, not the easiest, but the most fundamental ramp that makes no assumptions about prior background knowledge. This is truly an introductory course. So that being said, what we're going to test you on, or we're going to ask you, okay, what do you know about data? And that's a huge component that I think so many stats courses don't have. Okay, I know I'm giving you a big sell on that, but then we're going to go to probability tables and relative risk. I want to emphasize, if I'm going to bin something, I would bin weeks 5 and 6, or modules 5 and 6, and modules 2 and 3. Modules 2 and 3, essentially, we have the first 3 modules about data, but the first module is really the introduction to data. It's more of an overview. 2 and 3, we're going to talk about categorical and numerical data. Okay, keep those distinctions clear. We're going to ask questions about those. Then we move from there to probability and relative risk. And then we have which is kind of a method, you could say. It's a way of thinking about categorical data. And then we talk about correlation and simple linear regression. And I sort of put a circle around correlation and simple linear regression. For me, I wouldn't say everyone would agree with this, but they both have strong assumptions about what is the association between one variable and another. And then they also have strong assumptions about linearity. However, there's a huge distinction one distinction that is extremely important is when you distinguish between simple linear regression and correlation analysis. And this is that the order of analysis of prediction and your X variable and your Y variable matter when you talk about simple linear regression. It doesn't for correlation. Correlation just tells us whether or not there's a relation between one variable and another. And that relation, that measure of a strength of association, is measured by the correlation coefficient. The linear correlation coefficient measures the strength, but it does not tell us what is the predicted value of one variable given another. In contrast, the simple linear regression actually depends on the ordering of the analysis. And actually that's in, I think, one of the quizzes from week 6, where we ask, well, what is the order there? We give sort of a verbal answer. But if you look at even like the equation for the simple linear regression, we have y equals b naught, you could say, that's the intercept, plus b1 times x, right? The little asterisk here is just a little times, and this is x here. Whether or not we solve for x or we solve for y, let's assume we have values for the slope and intercept that are constant. If you apply if x equals 2, then you get an answer, as opposed to get a different answer than if y equals 2, and solve for y. So this requires a little bit of algebra, but the point is, if you switch the order, if you switch the placement of the variable that you use to predict in linear regression, it actually changes the outcome. It's just some math there. But it's also logically, it's analogous to sort of a conditional probability in a way, because you're essentially saying, well, no, actually it's analogous, because you're essentially framing the problem in terms of, okay, given that we know variable x, what is the predicted value of y? And correlation analysis does not do that. However, that both correlation analysis and simple linear regression, both are linear models, right? A model here is a representation of the data at hand. And this is all just to describe the data, to predict the data, to understand what's going on with variables in the data sets, these columns of data and their associations. Okay. I didn't mean to bloviate that much on stats, but and I know some of you have to go, so if you need to go now, please, by all means. But otherwise, I'm just going to go through the probability tables and measures of relative risk. So let's see if I can. Oh, sorry. I need to open the mouse here, and I'm just going to. So I hope it'll give you an idea also of maybe how I would sort of address the other weeks as well. So here you see the output here of different variables. Notice here we talk about proportions. And we talk about proportions as probabilities. We talk about the probability of not having health insurance. What does this mean? Well, here we're talking about characterizing categorical data, right, of a 2x2 table in terms of a probability. What does that mean? Okay. Well, we're basically saying this is just a framework for thinking about things. So this is where I think some students, when they're taking the practice exam, are like, what is the probability that something is going to happen? And that's a key word. If we're asking for you to write in a probability, make sure you write it in a decimal place. Most of these are conceptual, and we can talk about some of these issues, but I'm just going to move ahead and show you the question, the equation that I would focus on. I apologize if I'm going too quickly. Okay. So here we talk about joint and disjoint probabilities. So first you should know that distinction, but I think to work with joint probabilities, it's really important to, I think this is a key example. Like this is an equation that I would have at hand. I'd probably even have it tagged to maybe this little picture here, and maybe even work through in my own mind what are the answers that I can solve? What information can I derive from, say, this output here in this worked example? So the idea is essentially when you take a table of counts, you can divide by the total n, each cell, and you'll get basically the proportion of the probability. And these are going to be disjoint probabilities if they add up to 1 altogether. If each column adds up to 1, then you know that it's a conditional probability. And unconditional is the same as essentially saying it doesn't matter, again, which way you order your probabilities. Oh yeah, thank you. Someone's asking which slide number. I apologize. I meant to say that. So I want to take you to the week on probability, week 4, and the first equation was, I would start with, so when I look through this is how I review things too. If I didn't write anything down, I would skim over the slides and look for the math basically and write down some of the math. Don't write down everything, but you can even just cut and paste it. I would look at part 2, because part 2 is really where we have a lot of these probabilities, working with probability tables. The reason I'm cluing you on this is that I think there are more equations in this week than there are in others. So part 2 is on slide 46. And keep in mind, I think in some ways less is more. Week 4 has 126 slides. So I'm saying not to ignore the rest, but for me, looking at this, I'm going to go look at some of these nuts and bolts equations. And when you look at joint probabilities, joint and disjoint probabilities, I would look at slide 53, where we're defining joint and disjoint probabilities. We're never going to ask you to write out equations, but they're useful for thinking about issues, that we address in class, that we address that. Yeah, Walter, that's a really good point. So there are additional examples for practicing probabilities if you want more problems, right? If you want more analyses. Now, the first equation I actually directed you toward is this one right here, which is your, basically estimating the joint probability. And this is, what slide is this on? This is on slide 54. So slide 53 defines a joint and disjoint probabilities. A joint probability is simply that there's an overlap here. And this is a crucial issue. right? This little green bit here. So when we ask for the probability of A or B, typically we have a very technical term that we're not asking for the probability of A and B. We're talking about A or B, not A or B and A and B. I know that's a little confusing, but it's an issue for joint probabilities, not so much for disjoint probabilities, because the probability of A does not overlap with probability of B. So I think that math, at least it depends on how you think. If you're visual, think about probability in terms of the Venn diagrams. Okay, joint means there's a joining there. Disjoint, there's no joining, right? If you like the sort of Boolean logic of the math there, that would help. If that seems a little confusing, here we have sort of a verbal example. And I would say, yeah, it's useful to sort of work through the homework assignments for that week as well. But hold on. On slide 53 of week 4, you define those. And then you talk on slide 54, we basically show that with joint probabilities, the probability of A equals the probability of A and B plus the probability of A and the contrapositive of B. In other words, A and not B. Now that's important because if you think about it, we're basically trying to say, okay, not A and not B is this blue part here, and then we're going to have A and B, which we have to explicitly define. Now we have a couple rules. We can talk about the multiplication rule. This is where I want to scroll down pretty quickly. And so look at, for week 4, look at the rules. So the first rule that we have is the addition rule. And this is something crucial to write down, I'd say. Honestly, if I'm going to flag you for something, just write this down. Now the key issue is the probability of A or B, 2 events, is the probability of A plus the probability of B minus a joint probability. Now, check this out. If the probabilities of A and B are disjoint, then what's the probability of both occurring? 0. So you're just adding up this disjointed 2 separate non-overlapping circles there, 2 non-overlapping sets. There's disjoint probabilities. It's easy to do. Now, if there are joint probabilities, then you have to subtract the probability of A and B. And this is, again, a distinction between logic and then also the way we might use, do you want to go to the zoo or go to the movies? Well, sometimes you can have your cake and eat it too. We want to separate that. We don't want to have any kind of, we want to subtract any kind of overlap, especially if we're talking about joint probabilities. But the point is that the addition rule is applicable to both disjoint and joint probabilities. The only difference is that that overlap is always going to be set to 0 for disjoint probabilities. Okay, but write this one down because it's something that I see a lot of students will add up probabilities A and B, but they won't subtract their joint probability. Right, so this is in bold, right? This is not the same as using or commonly used in everyday language. The probability of A or B is defined as the probability that A occurs or that B occurs, or that both A and B occur. So when do we use the addition rule? When we have 2 events and we want to know the probability of at least one of the events occurring. Keep in mind, just for your own notation, right, this union sign is also, so it's the union, so it's A or, and similarly A and is the intersection. And the intersection is, again, this is set theory, but intersections, I think it's typically when they overlap, and then the union is kind of the whole surface area. So the point we have here is when we talk about the addition rule, look at this example here. If we have 2 probabilities, probability of 0.5 and 0.15, and we know what the intersection is, and we know what the sample space is. Sorry, not the sample space, but the oh yeah, the sample space is, then we just want to make sure that we're not double counting this overlap. This is for joint probabilities. If there's no overlap, there's no issue. So that's the main points. We subtract the intersection of two, you could say, joint probability sets. Now we have a different, the other issue is, well, why are we throwing you do two different equations for the addition rule? We have a part 1 and part 2. I would say if the first most important equation for week 4 is going to be the addition rule for part 1, which is, what is it? I'll tell you the slide now, sorry about that. Sorry, it looks like my computer's a little slow. Okay. Sorry, I'm gonna do a keyword search. Addition rule. Okay, the addition rule is this thing right here, right? So, and this is on slide, looks like it's on slide 68. So first, issue is slide 68. That's the most important equation. If you have to remember one equation for the probability, that's the one. But we have this in two parts. Then on slide 72, we have part 1, probability of A or B equals A plus B minus the intersection, right? So you subtract the intersection. And then we have on page 73 of the PDF, we have probability part 2, which is slightly different. You're doing is a little bit different information. You're saying the probability of A or B can also be probability of A and B, their intersection, the probability of A and not B, and the probability of B and not A. Right, because this is the probability of B and not A. You're just taking off that white part, basically. The probability of B and not A and not B, and then here's the joint probability. That's essentially the second part of the addition rule. And you can also think of A and not B as also only A. So I think the addition rule for part 1 and part 2, all we're doing, just to be clear, we're just saying you can find out the probability of A or B using different bits of information. One is if you know what the whole circle probability is for one set, the other circle for the other set, and you subtract that overlap because you've already counted those. The other way is to think about the probability of A or B as their intersection, and then the non-overlapping parts. And if you notice, reviewing the homework, we actually ask you those in the problem sets that you've employed before. Sorry, in the missions. For the mission of this week, we actually ask you both in the data analysis and in this. And actually, I think mostly in the responses, we ask you, okay, given that you know this and you know this, what is the probability of A or B? And I think for the second part, for the part 2 of the rule, I think the more difficult part is just conceptualizing the fact that these different expressions of the addition rule, it's the same thing. It just, all we're saying is, okay, there's more than one way to, pardon the expression, skin a cat. There's more than one way to accomplish the goal. That's all. You're just taking different puzzle pieces and seeing what blue, yellow, and greens add up, so that way you can do A or B. You can look at the overlap there. And here are those examples of how you use pieces of information. Explicitly, this is how we did it in the homework assignment, but also how it will be for the final exam, or for the midterm, sorry. Which is, okay, here we have the probability of something and not something else. Okay, probability of poor or no health insurance is the addition of each one minus 0.09 equals 0.41. Okay, well, how do we do this? Well, we said, what is the probability of being in poverty or having no health insurance? Well, the probability of being in poverty is right here, because this is where each cell adds up in its row to give you what we call a marginal probability, or we could say the probability of each of these disjoint probabilities here. So we ask, so that's the probability of living in poverty. What's the probability of having no health insurance? Well, it's 0.12. Okay, so here we have the addition rule applied, and it's very, very common to add 0.38 and 0.14 and think, okay, I have here the probability of health insurance. You know, you basically have, I'll just draw this. Right, you have the probability of one circle on the Venn diagram. And then here you have the probability of another. I'll make this blue. Well, I should say, I'm going to clear this. I want to clear all drawing because technically here is one overall probability of, say, probability A. And then here's probability B. Oh, I wanted to do a different color. Okay, well, I'll do that again. Probability B. So here's a probability of A, probability of B, and then you want to subtract, though, their intersection. And this is just the addition rule. And we have different expressions of the addition rule because we can sort of say, okay, well, the probability of A given not B is, you know, there are different recombinations of these cells and of these values here, just to basically say, given the information that we give you, you know, at hand. You don't have to have all the information. You can actually use different bits of information to come up with the same conclusion. But by far the biggest issue that I see with probability is this addition rule. People are not subtracting the intersection of these two probabilities. The reason we're doing that is because we want to subtract out what we've already counted in probability A or B. And we don't want to double dip, essentially. And that's for joint probabilities. Okay, I hope that's clear. I think that you just, sometimes with stats, to be honest, you have to be comfortable with, I don't want to say uncertainty, but comfortable with discomfort. I think, especially when you talk about probability, it's counterintuitive. It'll trap anybody up. Trust me on this. But it's a crucial issue. But that's also what makes it really cool. And stats very powerful. The model will typically tell you things. Probabilities will report to you. You should not report to them. Okay. Then I would go through the example, the second example, where we talk about, okay, what is the probability of living in poverty or having no health insurance? We're essentially asking you to estimate the probability using different bits of information. This is on page 74 of week 4. Now, what do we do here? Oh, sorry. Page 74 is where we do part 1. 76 is where we show you how to do the bits and pieces for the addition rule part 2. And essentially, we're asking you, what is the probability of living in poverty or having no health insurance? Okay, we're just showing you how a different way to answer the same question. We show that you can add, you know, the probability of being poor and the probability of having no health insurance, and then we can subtract their intersection. We can also do something else. We can get to the same root if we say, what is the probability of not having health insurance? See, okay, I'm going to trap myself up. Let me look at this equation one more time. See, even I have to look at the equation every once in a while. Yeah, probability A or B is probably the joint probability, and A and the not B, B not A. Okay, so so you could say this is basically what you're doing is you're taking the probability of being poor and not having health insurance. So this is, sorry, not having health insurance, which is this little value right here. The first value, though, is the intersection. So you take the intersection, and then you take the probability of not having health insurance, and then you add also the probability of not being poor. And that's this right here. And essentially, if you want to visualize it, just go back to the equation for part 2, and you can see that you're just taking this blue part, this yellow part, and where they intersect. Okay, well, that's essentially what we're doing here. Blue part, yellow part, and where they intersect. That's it. And the reason this is crucial is that sometimes we might not provide this column information if you looked at the problem sets. That being said, you could actually figure those out, but still, that's crucial. And if you notice, if you look at these answers here, this is about reporting and defining probabilities. You can say probability is relevant here when you think about probability. You're going to report it in 2 decimal places. Okay, I'm going to get rid of this language. And I know I'm going longer than usual, but look, this is kind of a, I would have to say there's quite a bit of material here to cover. We do talk about conditional and unconditional probabilities. I feel like we covered that quite a bit, but let me know. I think that's not a case where we have the equation to focus on. I want to take you to the multiplication rule. So we have the addition rule, two formats, then we have a multiplication rule. The joint probability of events is given by the probability of A and B is equal to the probability of A given B times the probability of B. Or the probability of A and B is also the probability of B given A and times the probability of A. And it can help us find, what do we say? It helps us find joint probabilities when we have conditional and unconditional probabilities. In other words, it can basically talk about how to join probabilities. What is the overlap there? What is the intersection there? Where do the two Venn diagram charts overlap? That's what the multiplication rule is for. Now, if they're independent, you could say, okay, you're just multiplying probability A times probability B to know what the joint probability is. That being said, you could always use, assume that probabilities are not independent, right? So there's a conditional probability. If you make that assumption, you're pretty much safe. In other words, you could say the probability of A given B times B is the probability of A and B. In fact, you could even write this as one equation. If you want to reduce your text, I could write this, and then you could also do this is also the same as to say, I know it's not exactly written out here, but I don't have time to write out everything, but shoot. Well, I was going to say, you could actually say this is equal to this, which is also equal to this. Sorry, this. Right? So the probability of B given A times A is equal to the probability of A given B times B, which is equal to the probability of A and B. Just keep that in mind. Okay. And also, so this is on slide 91 for week 4. Okay. So the multiplication rule, we covered the two addition rules. And then we have on 93, we have part 2 for the multiplication rule. We could talk about the conditional probability. What is that? It just means, what is the probability of A given B? Given that we know B, what is the probability of A? Well, it's the probability of A and B divided by B, probability of A and B divided by A. These are just to, solve for some other issues. So, and that's on page 93. So we have 93 and 91 for the multiplication rules. Okay, we're not going to ask too many questions about probability trees, but I think they're another way to clarify and understand these, the concepts at hand. But yeah, familiarize yourself with, maybe you could review the homework assignment and just familiarize yourself with the homework. The last thing we're going to talk about is, in addition to the multiplication rule and the addition rule, we have relative risk. Now, this is like crucial. We're going to ask you some conceptual stuff. Keep in mind relative risk conceptually. What does it mean? Well, on its own, it just tells you literally the relative risk of something. So you could have a high relative risk, but an overall small percentage. This is where context is important. So let's say the prevalence of death by lightning is 0.00, I'll just say 0.001, right? Well, what does that mean? If we talk about, say, jogging outside, it has a relative risk of 2.0. It doubles your risk of getting struck by lightning. Well, that means it basically doubles a very small percentage if the overall prevalence is low. Again, it's right in the words, relative means you're just increasing the relative risk. You're not increasing the risk in an absolute sense. It's all relative to what the baseline risk is in the unexposed group. Right? What is the overall, you could say even use an overall prevalence, but technically it's the non-observed group. And think of this in terms of a ratio. When we talk about ratios, just to be clear, absolutely clear, a ratio is actually just one variable or probability divided by another. I know this seems elementary, but it's actually, statisticians, we don't like ratios. Biologists, I know, love them. My girlfriend is a neuroscientist. They use ratios all the time. We don't like them. Why? Because you're actually bundling quite a bit of information. That being said, we find them useful, but a relative risk is kind of hides some information. But just remember that it's a ratio of probabilities, relative risk. And so you can have a high relative risk, but an low overall prevalence. A good example of this is actually cigarette smoking. Cigarette smoking will actually, I think, increase by tenfold your relative risk, your risk of your probability of dying by lung cancer. So the relative risk for smoking, I believe, in lung cancer is something like 10. It's a very high relative risk. Keep in mind a relative risk of 1 means that there is no increased probability of an event exposed versus the event not exposed. It's equal. There's parity. If this value up on top in the numerator, I believe, the bottom is the denominator, if the probability of exposure is 10 times higher than the probability of the event given non-exposure, then you're going to have a relative risk of 10. So the point is, relative risk is not a probability itself. It's a ratio of 2 probabilities. And those are expressed in terms of decimal places. So we could have points, zeros, I think I said 0.001, but let's say 0.01 divided by 0.001. That would be a good example of something where you see that prevalence, the proportion is still quite small, right? In terms of like the exposure rate. But 0.001 divided by 0.01 divided by 0.001 is still a tenfold increase. And that's why relative risk can be a little shady. You want to know the absolute risk to know the context. You also want to know perhaps the social implications. If you want absolute zero reduction in terms of the event itself, in terms of risk analysis, a lot of people I know work in risk analysis. Many people would say, we want an absolute zero risk of say a nuclear bomb going off, right? This is sort of a lot of stuff. I know people at Harvard, they have a group called Tracking the Bomb. Okay. Well, any risk above 1, or any risk that doesn't perhaps reduce the probability of an atomic disaster is essentially, MAD. We could say mutually assured destruction. So this is where context is important. But write this equation down. Know more about the concepts and the interpretation. A relative risk of 1 doesn't increase by 100% or anything. Remember, it's a ratio, so its value can really go from 1 to infinity, right? Or not to infinity really, but to as high as you want. You could have a relative risk of 100. It means, let's say, I don't know, I drink polonium tea and I get radiation sickness. Well, drinking polonium 205 tea is going to expose my body to carcinogens, and I'm going to have a hugely increased risk of radiation disease. That's a huge relative risk ratio, and that number can go as high as you want. That being said, a reduction in risk is only bound between 1 and 0. So a relative risk of, say, 0.5 over 1 means you have the risk. It means that this numerator is smaller than the denominator. So that's an important point to keep in mind. RR less than 1 or 0, you reduce risk. RR greater than 1 can go as high as the data present, the coefficient, you could say. But it's really, the interpretation is really still contingent on what is the prevalence, what are the probabilities, what is the context. Okay, now that being said, yeah, we'll ask you some math here. Now the math we're gonna ask for you, if you look at slide, this is, I think, somewhat useful. I don't want to say it's not useless, but I would actually emphasize perhaps slide 122, because I think that illustrates how you can estimate the relative risk. essentially as a ratio of different kinds of probabilities, but these probabilities themselves are calculated as from different ratios. Now, typically what we did in the homework assignment is we had you estimate the conditional probability of the event given exposure, and then we had the conditional probability of the event given that you're not exposed. Now, keep in mind, these intermediate steps are not always assumed. Sometimes they're given, but you have to estimate these perhaps from the data at hand. So this is where I think relative risk gets really confusing for a lot of students. It's not just, we're not going to give you always the data at hand, but we might ask you what are the elements here. We might ask you to estimate the numerator from the table. Well, what is that? That's 0.24. Where does that come from? Well, that's probability of not I and P over the probability of P. So this is a probability, I guess, of not insured given exposure. Yes. Sorry. Sorry, I got a little P and I confused here. Okay, so keep in mind when you see this little bar here, you're talking about the absence of something. Here you're talking about the presence of something if you don't have a little bar on top of the indicator for the probability. What we have here is we have, first of all, we have disjoint probabilities. We have marginal probabilities. So what we're really doing is we want to know, okay, what is the probability of not having health insurance? So what is the risk of not being insured given that you're poor? That's the risk group, it's red. Well, that probability is going to be 0.009 divided by the probability of being poor. So we're taking into account that the probability of being poor. What's the probability of not having health insurance given you're poor? That's a conditional probability of not having health insurance given you're poor. And you're going to, that is equal to 0.9 over 0.38. Okay, we estimate that. And then we take, then we estimate what is the conditional probability of not being poor given that you have health insurance. Sorry, not being insured given that you are not poor. So the risk group is poverty or not, right? So and that's 0.603. So this is not being uninsured given that you're not poor. And what we're doing is we're just taking into account the prevalence of the marginal probability here, the overall prevalence of each group, of exposure to the risk, you could say. Here we're taking into account, okay, well, what's your probability of not being insured, taking into account how prevalent poverty is for you. Okay, so there are 3 steps here, right? So we just basically estimated the green here, so the red here. This is your exposure, probability of event given exposure, and that's just a ratio of the disjoint probability over its marginal probability, right? 0.09 over 0.38. And then given the probability of the event given non-exposure, which is going to be much smaller, right? Because if you're not poor, you're much more likely to have insurance. You're less likely to not have health insurance. So that's only 3% of the entire probability space, but it does constitute a larger proportion of the population. Okay, you have to factor that in. So here we have then, what do we have here? What are these results? These are actually, these ratios are conditional probabilities, right? It's a conditional probability of event given exposure. And then below, and then in the denominator, you have the conditional of the event given non-exposure. So you take those probabilities, and then you have that statistic here. You have the relative risk. I know this isn't very fun. Trust me. This is why, if you're going to bookmark a page, and honestly, I would print it out. If you have a color printer, it also helps. Let me make sure I got this. Shoot. I want to be absolutely clear here that I show this to you. Okay. Go to page 122, week 4, 122. That'll give you relative risk. The rest of this is interpretive, but I hope that wasn't too much of an explanation. I know it's like 640, it's probably going too long. There's a lot of material here. But I did give you, I think, what are the most important equations. The other equations, know the equation for correlation. You're probably gonna have to solve for some elements on the right-hand side of the equation, given what the correlation is. So we might ask you, what's the correlation, what is the, say, standard deviation given the correlation? I know, I don't like probability either. Someone said, thank you, I appreciate the kudos. This is why I say, in some ways, be comfortable with confusion, because notice how I got tripped up. Okay. The reason is that probability is at the fundamental. It's also counterintuitive. This is why we have this is why the casino. This is what keeps casinos in business. I think that's it. I don't want to go too far on. I just stopped the share. I could go on, but I think the other equations are for simple linear regression as well, and then the regression, the equation for correlation. You should also know, by the way, some of the simple, the empirical rule and the Chebyshev's rule, if you remember that from a correlation. I'm sorry to hold you on, especially if you're busy. Please feel free to go. But I do just want to share with you the correlation equation here. Just keep in mind, we're going to ask you some questions about the empirical rule and the Chebyshev's rule. I'm not going to go that here, but those are just simple heuristics. What I want to show for you is just what correlation, what's the correlation to write down? Sorry, what's the equation to write down? Right here. This is page 73 for week 5. This is what I want you to focus on. This equation right here. Keep in mind it's linear, simple linear regression. It has basically 3 bits of information. Sample standard deviation of y, sample standard deviation of x, sample covariance of x and y. Okay? Keep in mind those are 3 bits of information, and that gives you the correlation. So you have 4 bits of information. We're going to ask that you solve probably for one of those. We're going to ask you, what's the standard deviation, sample standard deviation of x? What's the covariance of x and y? And then we'll give you the sample standard deviation of x or sample standard deviation of y and the correlation. Or we might give you the variance of x, the variance of y, and the correlation. Okay, keep in mind variance, the square root of variance is the standard deviation. So the point is that the correlation equation is going to be important here. You don't have to distinguish between, say, the Greek symbols for population and then for a sample, but that's still relatively relevant. I wanted to show one other thing for you is if you have any doubt, if we ask you to sort of assess the subjective association, there's this table here. If you're in doubt about, we're not going to ask you too many interpretive questions about what is a strong correlation, because that, again, depends on context. I know that's on one of these pictures here. I just want to show that to you, if I could. Well, okay, yeah, here's a rule of thumb. Okay. No, I'm sorry. Well, if you can find there is a table of correlations that is roughly pretty relevant. That's absolutely right. Walter asked a good question. We can always check with R code. So that's one thing. If you do want to use R is a fancy calculator. You can do that. I didn't really go through that. I think mostly because we don't want you to be too hooked onto a particular programming language. Because trust me, you talk to some R people, they hate Python people tend to hate R people. Stats is a universal it's a way of thinking. But yeah, if working within the R environments and sort of playing around with data is your way of thinking, I'm certainly a very much sort of a hands-on kind of person. I think that's the way I learn best. Go ahead. I think that's very useful. In fact, if you look at, I think my own preparation when I first audited the course, you'll actually see that I had I actually took all the data sets and I put them in one folder and just sort of analyzed them just to sort of see, okay, This is how this is how you can think about the relationship between things. If not that, any simple kind of calculator for simple addition, ideally with a log transformation or square root function, that will be useful. But we're not going to ask for any difficult math here. Any other questions, any other issues? I think we've gone well over the section. I apologize for going too long. I know I probably kept some of you longer than you desire. But any other issues? If not, we can definitely address them on Thursday. And of course, please meet with me in person. For Thursday as well, I just want to emphasize, I'm going to start holding office hours because in the second half of the term, well, actually, I'll stop the share. I just want to say, if there are any other questions, please let me know. Oh, good. Okay, thank you. I'm glad. Okay, yeah, of course. Any other questions? You guys all right? We can't cover everything. We covered the hardest stuff, though. Stuff that I don't like. Okay. Yep. Bye, guys. Bye, everyone. Oh, I just want to say, I almost interrupted myself. I apologize. I'm going to start holding office hours. Feel free to make use of that time. Okay, so those of you who have, great. Those of you who haven't, totally understanding. But I'm going to hold open office hours. That way people can ask questions in private, that kind of stuff. All right. Okay, and there's no such thing as a stupid question. That's my other mantra. People will say this, never a stupid question. Okay, bye. Good luck. Let me know how everything goes. If you have any other complaints, feel free. Especially like, I appreciate the point about percentages and units of, you can say units of analysis, but for statisticians, we're so data heavy, we're gonna think about the data. Say units of expression. And the reason I'll say that is that I actually looked at the slides and it looks like we're talking about proportion. We're talking about sometimes about decimal places. And we talk about that with probability too. So I want to make sure we're consistent, and if we're inconsistent, that's not good at all. But generally, I would say when you talk about probabilities, probability is expressed in terms of a decimal place bound by 0 and 1. All right. That's all. Proportions, technically it's a percentage, but proportions we could sometimes express as, this as well. 100% or 0% in terms of percentage. Okay, anyway, I don't want to talk anymore. I don't want to let you go. I'll let you guys go. Thank you so much. Have a great evening. Good night.